Okay, so still on our lecture series on motion, here we'll be looking at this example. So the example that I have here is the displacement of a body in a position x direction is given as x is equal to 3t raised to the power of 3 plus 2t raised to the power of 2 plus 4t plus 5. Find the velocity and acceleration of the body after 5 seconds. So this is a very simple question. So we're given that the displacement of the body x is given as what? 3t raised to the power of 3 plus 2t raised to the power of 2 plus 4t plus 5, right? And we are asked to find the velocity and acceleration of the body after 5 seconds. So since we have our displacement to be x, what is velocity? Velocity is given as velocity v is equal to what? Displacement over time, right? So since we have our displacement to be 3t raised to the power of 3 plus 2t raised to the power of 2 plus 4t plus 5, what are we going to do? What we're going to do in order to look for velocity is that we're going to differentiate x in respect to t, because velocity is what? Displacement over time. It is change in velocity over what? Time, over change in time. So our velocity is going to be a differentiation of x in respect to what? T, right? So velocity, if velocity is changing s in respect to t, velocity will be equal to what? Dx over what? Dt, right? Changing x in respect to what? T. So this will be equal to. So how do we differentiate this? How do we differentiate this expression? So we differentiate this expression using the general principle of differentiation, right? And the general principle of differentiation, it states that if y is equal to x raised to the power of 3, then the y over dx, which is changing y in respect to x, will be equal to, I will use this power of 3 to multiply this x, so that will be 3x, and I will subtract 1 from the power. 3 minus what? 1. So that will be equal to 3s raised to the power of what? 2. This is our answer. So if we apply that, this is the general principle of differentiation, right? If we apply that principle here, my dx over dt will be equal to, I will use this 3 to multiply this 3. So I will use this 3 to multiply this power of 3 to multiply this 3t. So that will be 3 times 3t will be what? 9t, right? And I will subtract 1 from the power. 3 minus what? 1, right? Plus, I will use this 2 to multiply 2t, this power of 2 to multiply this 2t. So that will be 4t raised to the power of 2 minus what? 1, plus, there is an invisible power of 1 here, right? Anything raised to the power of 1 is equal to that number, right? So this will be 1 times 4, which is 40. 1 times 40 will give us 40 raised to the power of 1 minus 1, because there is an invisible 1 here, right? Plus what? Since 5 is a constant, if we differentiate a constant, it will be what? 0. So that will be plus what? Plus 0, right? So this will be equal to 90. 3 minus 1 will give us what? 3 minus 1 will give us 2, plus 40 raised to the power of 2 minus 1 will give us what? 1, plus 40 raised to the power of 1 minus 1 will give us what? 0, right? So this will be equal to 90 squared plus 4t plus anything raised to the power of 1 is what? That number. So t raised to the power of 1 is the same thing as t, right? So that will be 40 plus what? Anything raised to the power of 0 is what? 1. So 4 times 1 will give us what? 1. So that will be plus what? 4. Anything raised to the power of 0 is 1. So t raised to the power of 0 is what? 1. 1 times 4 will give us what? 4. So this will be equal to. So we are asked to find the velocity and acceleration of the body after 5 seconds. So your t is what? 5 seconds. So that will give us 9, open bracket, 5 raised to the power of 2 because our t is what, 5, right? So plus 4 times 5 plus what, 4. So this will be equal to 5 times 5 will give us what, 25, right? 25 times 9 will give us what, 225, plus 4 times 5 will give us what, 20, plus 4, right? So 225 plus 20 plus 4, that will be equal to 249 meters per second. So this is our velocity, right? Our velocity is equal to 249 meters per second. Then the next thing that we have to look for is the acceleration. So here I'm going to look for my acceleration, right? So we know that acceleration is equal to what? Velocity over time, right? Since acceleration is equal to velocity over time, we have been given here is that our velocity is what? 90 squared plus 4t raised to the power of 1 plus 4t raised to the power of 0, right? And that gave us 9t raised to the power of 2 plus 40 plus what? 4, right? So this is the velocity that we got, right? So what we're going to do here is that we're going to differentiate v in respect to t, right? So our acceleration will be equal to dv all over what? dt. And we have gotten our v from this first equation, or from the first question, to be what? 9t squared plus 4t plus what? 4. This is our v, right? So if we look for dv all over dt, we use the general principle, right? So dv all over dt will be what? Will be equal to, so since this is our v, if we differentiate v in respect to t, changing v all over t will give us our acceleration, right? So if we differentiate v in respect to t using first principle, this will be 2 times 90. 2 times 9, this power of 2 times 90 will give us what? 18t raised to the power of 2 minus what? 1, plus there is an invisible power of 1 here, right? So this will be 1 times 4t will give us what? 4t raised to the power of 1 minus what? 1, right? And then this is a constant 4. It has no t. So if we differentiate the constant, it will be 0. So this will be equal to 18t raised to the power of 2 minus 1 will give us what? 1, plus 4t, 1 minus 1 will give us what? 0, right? So this will be equal to t raised to the power of 1 is the same thing as t, right? So t times 18 will give us 18t, plus t raised to the power of 0 is what? 1. T raised to the power of 0 is 1. 1 times 4 will still give us what? 4. So this will be equal to, so we are asked to find the acceleration of the body after 5 seconds. So after differentiating this expression, our v, right, what we are going to look for is the acceleration proper by imputing the value of t, which is what? 5 seconds. So this will be 18 times what? Times 5 plus what? 4. So 18 times 5 will give us what? 90. 90 plus 4 will be equal to what? 94 meters per second square. So this is our acceleration. Our acceleration is equal to 94 meters per second square. Our velocity here is equal to what? 249 meters per second, right? Very easy and straightforward. So let's look at another example for more clarity. So here I have this question. The displacement of a body in a position x, direction is given as x, is equal to 3t raised to the power of 4 plus 2t raised to the power of 3 plus 4t raised to the power of 2 plus 5t. Find the velocity and acceleration of the body after 0.5 seconds. So what we're going to do here, first of all, is to write the expression down, right? So I have my displacement x to be equal to what? 3t raised to the power of 4 plus 2t raised to the power of 3 plus 4t raised to the power of 2 plus 5t, right? So What is velocity? Velocity is what? Change in displacement over time, right? It's displacement over time. So my velocity will be equal to what? Dx over what? Dt. What that means is that I'm going to differentiate x in respect to t, right? So this will be equal to. So using the general principle of differentiation, how do I differentiate this? So I will use this power of 4 to multiply this 3, right? To multiply this 3t. So that will give me 12t, right? 4 times 3t will give me 12t. And then I will subtract 1 from the power. So 4 minus 1 will give me what? 3. So that will be 12t raised to the power of 3 plus. I will use this power of 3 to multiply 2t. That will give me, so 3 times 2t will give me what? 6t. And I will subtract 1 from what? The power of 3. So 3 minus 1 will give me what? 2 plus. I will use this power of 2 to multiply this 40. That will give me 8t, right? And I will subtract 1 from the power. So 2 minus 1 will give me what? 1. So that will be t, 8t raised to the power of what? 1. Then there is an invisible power of 1 here, right? So plus. I will use this power of 1 to multiply this 5t. That will give me 5t, right? Then 1 minus 1, I will subtract 1 from this 1. 1 minus 1 will give me what? 0. So this will be equal to 12t raised to the power of 3 plus 6t raised to the power of 2 plus any t raised to the power of 1 is equal to that number. So this will be 8t plus any t raised to the power of 0 is 1. T raised to the power of 0 is 1. 1 times 5 will give me what? 5, right? So that will be 5. So this will be equal to, having differentiated this expression, the next thing I will do is to impute the value of what? Of t, which is what? 0.5. So this will be 12 open bracket 0.5 raised to the power of 3 plus 6 open bracket 0.5 raised to the power of what? 2 plus 8 times 0.5 plus what? 5. So this will be equal to 0.5 raised to the power of 3 is equal to 0.125, right? Is equal to 0.125. So 0.125 times 12 will be equal to 1.5. So this is 1.5 plus 0.5 raised to the power of 2 will give us what? 0.5 raised to the power of 2, 0.5 raised to the power of 2 is equal to 0.25 times 6 will be equal to 1.5. So that will be plus 1.5 plus 8 times 0.5 will give us 4 plus what? 5. So this will be equal to 1.5 plus 1.5 will give us 3. 3 plus 4 will give us 7. 7 plus 5 will give us 12, right? So that will be 12 meters per second. So our velocity is equal to 12 meters per second, right? The next thing that we'll do here is to look for the acceleration, right? Acceleration. So we know that acceleration is equal to what? Velocity over time. So what we're going to do here, since we were given that the velocity is equal to 12t raised to the power of 3, this is the velocity, right? 12t raised to the power of 3 plus 6t raised to the power of 2 plus 8t plus 5. Since we have our velocity to be this, right? Our acceleration will be equal to dv over dt, which is changing v over t, right? So we're going to differentiate v in respect to t here. So we would differentiate it using the general principle, right, of differentiation. So dv over dt, my change in v over t will be 3 times 12t. 3 times 12t will give me what? 36t. And then I will subtract 1 from the power. 3 minus 1 will give me what? 2. So that will be 36t raised to the power of 2 plus 2 times 60, 2 times 60 will give me what? 12t, right? I will subtract 1 from the power. 2 minus 1 will give me what? 1. Plus, there is an invisible 1 here, right? So 1 times 8t will give me what? 8t. So 8t. 1 minus 1 will give me what? 0. Because I have to subtract 1 from the power, right? 1 minus 1 will give me 0. Plus, if we differentiate the constant, it is what? 0. So this will be equal to 36t raised to the power of 2 plus anything raised to the power of 1 is equal to that number, right? So 12t raised to the power of 1 is still the same thing as what? 12t plus t raised to the power of 0 is what? 1. 1 times 8 is what? 8, right? So that will be plus 8. So this will be equal to, so since I have my equation already differentiated, I will have to, the next thing I will do is to impute the value of t, which is what? 0.5, right? So this will be 36 open bracket 0.5 squared plus 12 open bracket 12 times 0.5 plus what? 8. So this will be equal to 0.5 raised to the power of 2 is equal to 0.25, right? Times 36 will be equal to 9. So this will be 9 plus 0.5 times 12 will give me 6 plus what? 8, right? So 9 plus 8 plus 6 will be equal to 23. So this will be equal to 23 meters per second squared. So this is my acceleration. Acceleration is equal to what? 23 meters per second what? Square. So this is the answer to this question. So whenever you find a question like this, what you need to do is to first of all differentiate your x, and then after differentiating your x, you impute the value of your t, which is in seconds, multiply it, and then you'll get your velocity and you'll get your acceleration as well.